So if we accept that the world really does tick in this bizarre way, could we ever harness the long-distance spooky action of entanglement to do something useful? Well, one dream has been to somehow transport people and things from one place to another without crossing the space in between. In other words, teleportation.
Beam me aboard. Energize. Energize.
Star Trek has always made beaming or teleporting look pretty convenient. It seems like pure science fiction, but could entanglement make it possible? Remarkably, tests are already underway here on the Canary Islands off the coast of Africa.
We do the experiments here on the Canary Islands because you have 2 observatories, and after all, it's a nice environment.
Anton Zeilinger is a long way from teleporting himself or any other human. But he is trying to use quantum entanglement to teleport tiny individual particles. In this case, photons, particles of light.
Nanometers, it says.
He starts by generating a pair of entangled photons in a lab on the island of La Palma. One entangled photon stays on La Palma, while the other is sent by laser to the island of Tenerife, 89 miles away. Now Zeilinger brings in a third photon, the one he wants to teleport, and has it interact with the entangled photon on La Palma. The team studies the interaction, comparing the quantum states of the 2 particles. And here's the amazing part. Because of spooky action, the team's able to use that comparison to transform the entangled photon on the distant island into an identical copy of that third photon. It's as if the third photon has teleported across the sea without traversing the space between the islands. But could this go even further? Since we're made of particles, could this process make human teleportation possible one day?
Welcome to New York City.
Let's say I want to get to Paris for a quick lunch. Well, in theory, entanglement might someday make that possible. Here's what I'd need. A chamber of particles here in New York that's entangled with another chamber of particles in Paris.
Right this way, Mr. Green.
I would step into a pod that acts sort of like a scanner or a fax machine. While the device scans the huge number of particles in my body, more particles than there are stars in the observable universe, it's jointly scanning the particles in the other chamber, and it creates a list that compares the quantum state of the 2 sets of particles. And here's where entanglement comes in. Because of spooky action at a distance, that list also reveals how the original state of my particles is related to the state of the particles in Paris. Next, the operator sends that list to Paris. There, they use the data to reconstruct the exact quantum state of every single one of my particles, and a new me materializes. It's not that the particles traveled from New York to Paris. It's that entanglement allows my quantum state to be extracted in New York and reconstituted in Paris, down to the last particle.
Bonjour, Monsieur Green.
Hi there. So, here I am in Paris, an exact replica of myself.
I wouldn't step into that machine.
Whether or not human teleportation ever becomes a reality, the fuzzy uncertainty of quantum mechanics has all sorts of other potential applications.